We've talked about two special segments of triangles, mid-segments and medians, and both of those involved midpoints. Today we're going to talk about three other special segments of triangles: perpendicular bisectors, altitudes, and angle bisectors. Now, two of these, the perpendicular bisector and an angle bisector, we've talked about those with relationship to just an angle or a side. We haven't talked about it with a triangle, but it doesn't have any different definition. What's interesting, though, is just like with the medians, how all of the medians intersected at the centroid, or the center of gravity of the triangle, perpendicular bisectors, altitudes, and angle bisectors all coincide in the same place too. So if you look at it, a perpendicular bisector is a line that intersects through the side of a triangle at a right angle through the midpoint. It divides it in half. If I were to look at this one here, if I were to split this in half and draw a side that intersects at a right angle, and if I were to do the same thing here and draw this perpendicular bisector in, what's interesting is if I draw them right, they all intersect at a point. Now that point's called the circumcenter, and what's interesting about that is that would be the center of the circle that would go around where the triangle would have all of its points on the circle. Now again, you don't have to memorize that part, you just need to know what a perpendicular bisector does, but it's interesting information anyway. And altitude, these are really important when we get to algebra. The altitude represents the height of the triangle. It's the segment that extends from the vertex, so it's similar to a median because it extends from a vertex, but the altitude goes to the opposite side and makes a right angle. Where the median goes to the midpoint of the opposite side, the altitude goes to the other side and makes a right angle. Now again, these all intersect at the same place too, and in particular, like this triangle is a right triangle, it looks like that these two sides intersect, all three of those intersect right there. That's called the orthocenter. Again, not important, but interesting that they do all intersect. Then we have our angle bisectors. Angle bisectors are bisectors that extend from the vertex, and it divides that angle into two equal pieces. Now we can do the same thing. We can split this angle into two equal pieces here. We can split this angle into two equal pieces here. And what you'll notice is that all three of those angle bisectors intersect. That point's called the incenter, and what's interesting about it is the center of the circle that can be drawn, the biggest circle that can be drawn inside. That's particularly interesting and useful for for people who do these college banners that look like this, that want to do a big circle on the inside. They would find the center of that circle by finding the angle bisectors. Now, one thing that is important is if the triangle is isosceles, the median that extends from the vertex to the midpoint, the perpendicular bisector that extends and bisects that side at a right angle, the altitude that goes from the vertex to the opposite side at a right angle, and the angle bisector are all the same segment. And it's all because those two sides are the same. So if those two sides are the same, all four of those pieces are the same line. So let's look at some problems that would come up with this. Altitude first. So the slope of the altitude, find the slope of the triangle's altitude through point A. So remember that an altitude extends from the vertex and then goes to the opposite side. So it's going to extend from here at A, and it's going to extend and be perpendicular to BC. So why that's important is altitudes are perpendicular. And so what we need to do is we want to find the slope. Well, remember, perpendicular slopes are opposite reciprocals. So in order to find the slope of the altitude, we need to know the slope of the side that it's passing through. So if I zoom in here and look at BC, if I go find this, so it goes from 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and then over 1, 2, 3, 4, 5, 6. So it goes up 10 over 6. So the slope of BC would be up 10 and then backwards to the left 6. Okay, rise over run. That does reduce. If you reduce that by 2, then it has a slope of -5/3. That's the slope of BC. The altitude is perpendicular to that. So the slope that's perpendicular through A, so the slope that I want would be the opposite, so it'll be positive, and the reciprocal, which means you flip the fraction over. So if I were to test this, if I go from A, 1, 2, 3, down 1, 2, 3, 4, 5, I went negative, negative, which means it's positive, then my altitude goes like this. And that would be perpendicular because I know that perpendicular lines have opposite reciprocal slopes. So I can see where it passes and what the altitude looks like. But this is actually the answer to this question, is to find the slope. So to find that slope, I have to find the slope of the line that it's passing through, and then I have to find the opposite reciprocal of that because that's perpendicular slopes. So in 2, it says that JH is an altitude. That's given to you for a reason. That means that these angles are 90 degrees. Find GJ. Now, altitudes don't do anything in particular to the sides. It's not, if you go back and you look at the definition, all it does is it makes a right angle with the opposite side. So since JH is an altitude, and I don't know what happens to the sides, what I do know is that this angle right here should be 90 degrees. So I can say 3x plus 3 is equal to 90 degrees because that's what altitudes do. They intersect at right angles, which are 90 degrees. I can subtract 3 from both sides. I get 3x is equal to 87. If I divide both sides by 3, I get 87 divided by 3 is 29. So x is equal to 29. Now that's not what I asked for. I asked for GJ. Well, GJ is this piece right here. So GJ is x plus 8. Well, x was 29. So it's 29 plus 8, which is 37. So GJ is 37, and that's the answer to that question. Notice it doesn't matter that the x that I found had to do with the angles, and then I'm applying it to segments. That doesn't matter. X is x. It doesn't matter how you use it once you find it. So let's look at this one. Number 3, solve for x. So here's what's important is if you notice, look, this is equal. Those two are equal pieces, and this is a right angle that extends from that vertex. So that's the perpendicular bisector. That's the altitude, which also means, now we don't necessarily need it, but that this is the case too. Since that is all true, since those are all, since it is it extends, you have the altitude, you have the median, you have the perpendicular bisector. The reason that's important is because that means that this triangle is an isosceles triangle. That means that these two sides, MJ and MK, are congruent. They're equal to each other. So you set it up. 9x minus 30 is equal to 3x. Remember, in our world and everything in geometry, everything either adds up to equal something, the whole part, or it equals each other. Those are your two options. There's nothing for this to add up to be, so it has to be equal to each other. Okay, subtract 3x from both sides and add 30 to both sides. You get 6x is equal to 30, because that 3x canceled, so I moved the 3x over here, I moved the 30 over there. Basically, I just changed sides, and that means that x is equal to 5. All that because all of those pieces, MB is the angle bisector, it's the altitude, it's the perpendicular bisector, it's the median. So that means that that triangle is isosceles. Okay? If you want to make that note so you have it. Okay? Given that JMB, so remember JMB, that's this angle right here, that's 3x minus 15, and KMB is this angle right here, it's 5x minus 39, and angle K, which is down here, is 5x plus 9. Find the measure of angle K. So I look, and again, same picture, right? So this segment has been cut in half. This is at a right angle. It cuts everything in half. That means that this triangle, so triangle JMK, is isosceles. Okay, since that's congruent, It means these angles are congruent right here, your base angles. But even more importantly, because that's a perpendicular bisector, altitude, all of those things are the same, that means that these two angles up here at the top, this JMB and this BMK, are the same size. So 3x minus 15 has to equal 5x minus 39. We want to figure out what x makes that happen. So I subtract 3x from both sides. I'm left with negative 15 is equal to 2x minus 39. If I add 39 to both sides, then I get that 2x is 24. Divide both sides by 2, and you get that x is 12. Now, that doesn't answer the question. I asked for you to find the measure of angle K. So the measure of angle K is 5 times x plus 9. It's right here. Well, I just found out that x was 12. So it's 5 times 12 plus 9. That's 60 plus 9. So angle K is equal to 69. And that's your final answer. So remember, it is important that you understand when you're given the picture the effect that it has. The perpendicular bisector just cuts through a side at a 90-degree angle and it cuts it in half, but it doesn't go through the vertex necessarily. The altitude goes from the vertex to the opposite side at a 90-degree angle, but it doesn't necessarily cut that side in half. The angle bisector cuts the angles in half. The only time that it does all of them, that the perpendicular bisector goes through the vertex so that it cuts it at 90 degrees and cuts it in half, is when the isosceles triangle, when the triangle's isosceles. Then all of those pieces are the same piece. And that's helpful because then it tells us how we can work the problem because we know information about isosceles.